All right, nerds, now that we got the camera working, we can get this going. Whee! Algebra 1 stuff. Wait, that's... I'll be darned. I stapled the homework to the notes. Ain't that about to be? Okay, try again. There we go. I stapled my homework to my notes. I didn't do it for you guys. I did it for me. Here we go. Section 2.1. Hey, guys, trying to do a thing up here. All righty. Solving absolute value equations and inequalities. Today we'll just be working on the absolute value equations. Won't be doing the inequalities. My phone's blowing up. There we go. Okay, first things first, we need to recall what absolute value means. And unfortunately, math has not done you justice. You have been taught that absolute values just turn things positive. No, that's not what absolute value is. We've already addressed that in previous lessons. What absolute value does is it asks the question, how far from zero is this number? Okay, so let me ask you a question. What are the two values that are 5 away from 0? What are they? Brody, what do you got? 5 and negative 5. So here's what I know. I know that if I bet my teeth, it'd be a safe bet that most of you were taught that if you want to solve a question like this, what you do is set x minus 1 equal to 5 and negative 5 and solve for x, isn't it? Yes, it is. I know. Now here's the problem with that. It works great when things are really easy and hunky-dory, but it doesn't work great when things start to get really kind of crazy on us. See, it's not really a good option. And I can tell you, when you start doing absolute value inequalities, it could cause you real problems. So instead, I would like to train you to do it a very specific way, a way that I know always works. Is it always the most efficient, fastest way to do stuff? No, it's not. And I'll be the first one to say that. But the nice thing about my method is it always works. And I'm not forced to try to memorize when certain things do what. So grab some scrap paper right here. Here's what we know. Absolute value bars, because they tell us a distance from something, they could actually be hiding symbols from us and we would never know it. Brody told me there were two options for inside these bars that make this true, 5 and negative 5. So what I want to do, instead of playing with this, is I want to set my insides up to be different. And what I want to say is my absolute value bars could have been hiding that red structure from me. And I would have no way of knowing, would I? Because the absolute value of this is 5 and the absolute value of this is 5. Call this the best case scenario, call this the worst case scenario. Best case scenario is the inside of your absolute value bars was already positive. Worst case scenario is the inside of your absolute value bars was negative. And if you set it up with different insides, it'll always work, even when we get to the absolute value inequalities at a later point in time in this section. So I'm going to, one time, because I don't plan on doing this often, I'm going to write positive and negative. So this is the best case scenario. Best case scenario is that the number inside is positive. Worst case scenario, the number on the inside is negative. Cool. So if the number on the inside is positive, then the absolute value bars don't have a job to do because that number was already positive. But if the number on the inside was negative, the absolute value bars could have hidden that idea from me. I wouldn't have known the red structure was there because the absolute value bars would have canceled it to make it look like this. Now, if we solve these two, one where the inside was positive and one where the inside is negative, it'll always work. Am I going to get the exact same results right now as if I had just set this equal to 5 and negative 5? Yes. For now, yes. But in the future, no. I like one method. This method always works. Let me get a different color, purple. Let me add 1 to both sides right here. Boop, boop. And we know that x equals 6 is probably a solution. And you know what? It's really not that hard to check. Let's just make sure we didn't mess anything up. Let's take the 6 and plug it in. 6 minus 1 is 5. And yes, the absolute value of 5 is 5. Good. So easy. Doesn't take much time to check your answers. Please be in the habit of checking your answers. But here, distribute that negative sign as if it's a negative 1. And then solve for x. I'm going to subtract this 1, from both sides. and divide by -1 to get the other answer, x equals -4. And once again, it doesn't take much effort to test it to make sure it works. Take this -4, put it right there. -4 minus 1, that's -5. And yes, the absolute value of that is 5. Some of you, I know, it's probably a couple guys, are sitting here thinking, I'm pretty darn smart. I'm good at memorizing the rules. I don't need to know why they're true. He's going crazy. You don't have to do this much work. And I go, good for you. I hope it works out. But I'm telling you, I know what always works, and I know what gets students in trouble. And what gets students in trouble is trying to use a rule when they don't know why it's true, and because of that, they forget the rule and forget when to use it, which we'll see more of later on. Show of hands. Who in the room was really good at Algebra 1? Be honest here. Who was really good? Only 3 or 4 of you are going to say you were really good? Really? You're all in Algebra 2 honors right now. You're supposed to have all been amazing in Algebra 1. Like, when I say amazing, I mean amazing. Get a 5 on the EOC, my man Brody. Okay. Now, any of you that thinks you're really good at algebra, did you move ahead yet and do the second question without me? Has anybody already done it? Ryan did. Ryan, what'd you get? -5 and -1. Does anybody disagree with Ryan? Some people did. You see, some people worked ahead because they thought, whatever, he's just talking. I'm just going to move ahead because I've learned this stuff before. So, anybody want to give it a try real quick? Oh, you're trying right now? Okay. I'm going to leave the video on, that way they can see when we watch the video how long this takes before somebody tells me the answer. What if I told you Ryan was wrong? Yeah, what's up? There's not. There's no answers. There's no solutions. I don't need to do any work. Remember what we said? Absolute value bars ask you how far from 0 something is. How are you going to have a negative distance? How's something going to be -2 away from 0? So did Ryan do anything wrong? No. His algebra skills are actually very good. He did exactly what he knew he was supposed to do, and that was set up a positive case and a negative case and solve the two. The problem is, not all absolute value questions have solutions because you can't have negative distances. So, look ahead and try to think before you actually start solving, is this even going to result in answers? We good? Okay. So yeah, the numbers that you got, if you test them, tell you +2 equals -2. That's what they end up saying if you test them. It's funny, I got my wife with this question, something like this just a few years ago when she was teaching Algebra 1. She'd been teaching Algebra 1 for like 8 years. And I was like, I can't believe all my students missed this on their test. And she's like, what? And I just tossed a question just like this across the table at her and then let her do the Algebra 1 thing. She started working, got her 2 answers, and I was like, no, you're wrong. This is in the video too. And she's like, what do you mean they're wrong? She's like, what did I do wrong? I said, nothing. You didn't do anything wrong. Except for the fact that you started the question. That's what you did wrong. Because it's not possible. How absolute value bar is going to be equal to something negative? She was like, that's mean. That's not mean. It tests a knowledge of what the bars themselves mean. Because I told you, I like to write questions where students that know what they're doing look at them and they're remarkably simple. I've told you that before, right? Never know when it lands on a test. So this next one says absolute value of some stuff equals 4. That one works. People go, it's a trick question. It's not a trick question. It's a property of absolute value bars. Anyway, let's go ahead and solve this one. Best case scenario, the inside was positive and the absolute value bars didn't do a job. Worst case scenario, the inside was negative and the absolute value bars hid that from us. We're going to solve these two independent of one another, and we're ready to rock and roll. Let's first subtract 6. And just so you know, every period today, I had one person that moved. Actually, first period I had 3 people go ahead. But period 3, 1 person, and this period, 1 person. So I appreciate the 1 person who's brave enough to play this game with me. I really do. Anyway, subtract 6 from both sides, we get negative 2x equals negative 2. Dividing both sides by negative 2 gets us our first solution of x equals positive 1. It doesn't take much effort to plug it in and make sure it works. 2 times 1 is 2. 6 minus 2 is 4. And the absolute value of that is still 4. Good. We're happy. Distribute your negative sign. Negative 6 plus 2x equals 4. Then, PEMDAS in reverse order like we always do when we solve for x. And divided by 2 gets us our second answer that, of course, we are going to check it, make sure it works. X equals 5. Because it's not too much effort. 2 times 5 is 10. 6 minus 10 is negative 4, and the absolute value of that is positive 4. Whoop. Yay. So the next question. No solutions, right?
No.
Wait, no? Why?
Because it's negative 2 on the outside, so we get negative 3.
Oh, okay. Now the one thing we're not allowed to do is distribute that negative 2. Remember what I taught you about the absolute value bars? Treat them like jail bars. This is an outside change. It cannot mess with the inside stuff, which is another reason why we talk about transformations. What could we do with it? You can divide it. And that's what you need to do. First thing you do is isolate your absolute value bars. Get them alone before you attempt to set up the positive and negative cases. So I'm going to divide both sides by negative 2. I just want to have more vertical space, so I'm going to write it off here to the right. It gets me x minus 1 is equal to 3. You could probably just see what the answers are, and that's great. But I'm still going to show the work because I'm trying to develop the good habits for when the questions are not that easy. Okay? But once again, I want to make sure it's in this video at least twice. Isolate the absolute value bars before you try to set up your 2 cases. What's a good color I haven't used a lot of yet? Orange. Okay, I'll use orange. I'll use orange blue. Go Gators. It'll look like this red, but it is orange. So best case scenario, the inside was a positive number. Worst case scenario, the inside was not a positive number. And absolute value bars were hiding that from us. All right. I mean, that's pretty easy, right? Add 1 to both sides. Gets me x equals 4. You might as well check it. 4 minus 1 is 3. As value 3 is 3. 3 times negative 2 is, yes, negative 6. Good. Distributing the negative 1 here gets me negative x plus 1 equals 3. Subtract 1. And divide by, my math is having to get really short here. I'm running out of vertical space. Divide by negative 1, and I'll just stack my answer over here. X equals negative 2. And again, just check it. It's not that hard. Negative 2 minus 1 is negative 3. The absolute value of that is positive 3. And 3 times this negative 2 did get me my negative 6. Life is good. Not bad, right? At least I hope you don't think it's bad. You think it's terrible? Whatever. Sometimes I just say things because they sound nice, not because I mean them. Don't tell my wife. All right, next. Unless you have questions for me. Happy to answer them. No? You sure? Yes, sir.
If we didn't divide the negative...
the negative 2? Mm-hmm.
Would we have had to make it positive after we were done because of the invisible negative?
So, is there a way to do it without dividing by negative 2 first? Yes, there is. And what you're going to do is, I don't want you to do this, but what you would have had to have done is you would have had to have left this negative 2 on the outside, and then this thing would have been 2 different values. One was this, obviously, and the other would have been this. So you would have had this blue structure with parentheses around it and a -2 in front of that. And we don't want to do that. I want you in the habit of getting the absolute value bars alone before you try to set anything up. Always doing SAD/MEP, right? PEMDAS in reverse order. The absolute value bars are treated like parentheses. They'll be the very last thing that we deal with. So we strip everything away from them first and then deal with it. And you might be wondering why. And I go, well, let me just give you another example and show you why. How would you start that question? You would add 3. Now, is there a way to do this question by starting with dividing by 2? Yes, but it's not as easy, and you have to be a lot more careful. Now, yours is the same way. You had number, structure, equals some other number. Yeah, there's a way to pull it off, but we want to try to do PEMDAS in reverse order to try to whittle down to the thing we're solving for. Okay? So you want that to go away before you set up your 2 cases. Just like you would want this to go away before you divide it by 2. You could. You don't want to, though. So then for this one, what is going to be my first step? Somebody can shout it out. Got to add 4 first. PEMDAS in reverse order. We need this -4 to disappear. Pretend it says -1/2 x minus 4. Trying to get rid of that -4. Our job is to get the absolute value bars alone. So let's add 4. I haven't used a lot of red. Let's add 4 to both sides. I'll use black. -1/2 absolute 3x plus 6 equals 6. This is where we get rid of the -1/2. How? Multiplying by what? If we can start by multiplying by 2, but it's going to leave the negative sign there. There. But if we do it by -2, right now it gets rid of both things. So yeah, anytime you want a fraction to go away. Oh, look at that. If we multiply both sides by -2, that's going to give me the absolute value of 3x plus 6. Oops, that's supposed to be a plus sign. Equals a negative number. And this has no solutions. You can stop working. It's not a possible question. How about that? But you see, just the way it sits, did you know this had no solutions? No. But if you get the absolute value bars alone, then you can decide if it's going to be worth trying or not. You have question face over there. What are you thinking about? Yes, you. Yeah, you. You sure? Because your eyebrows said you had a question.
No, I was thinking about how, when I took algebra 1, I feel like I never
You might not have. Depends on who your teachers were and where you were. Oh, it was in New York. Oh, okay. Okay, up north is a completely different setup. And they don't have Algebra 1 in New York. Do they? I thought they had integrated 1, 2, and 3 up there. No, it's great, actually. Their system's much better than ours. Up north, there is no Algebra 1, Geometry, and Algebra 2. There's Integrated 1, Integrated 2, and Integrated 3. They mix all the platforms together. You know how every time I teach you something, I go, oh, Algebra 1 was 2 years ago? It doesn't work like that when you're in integrated mathematics because everything was, oh, I just did it last year. I just did it last year because it keeps coming up over and over and over again. You know when we were doing stretches and shrinks of graphs? That's also when you would have done stretches and shrinks of shapes. You would have done it there as well. I know, but the Florida system is, it rides a short bus. Okay, next. This question is near identical to this one. The only difference is there's a plus sign in front of that 4 instead of minus sign. So first, let's get rid of that plus 4. And now, like Jake last time said, multiply both sides by -2. We're going to do the same thing here. We are going to multiply both sides by -2. But this time when we do it, we will end up with a positive number on the right side, which means the question is 100% possible. There. Since it's possible, we set up our positive case and our negative case just like we've been doing in the previous examples, where the best case scenario is that that number on the inside was positive. And if it was positive, the absolute value bars won't do anything. Worst case scenario is, ooh, that number on the inside was negative, and the absolute value bars would have hidden that from us. But we're going to solve for x in both cases. Subtract 6 from both sides. And then divide by 3. Fraction. Sorry, it scared me. Or not. Okay. You know, often I've heard students be like, I must have done something wrong. And I go, why? And they go, because I got a fraction answer. I'm like, what? Who's hurt you in your life that you think that fractions are bad? Okay? Look, most answers are fractions. There's a lot more rational numbers than there are integers. Okay? Fraction answers are much more common. In fact, they're easier to write questions for too, because you don't have to care what the answer is going to be. You just write the question and let the answer be whatever the answer is. As a teacher, just so you know, it's easier for me to write a question when I don't care if the answer is a fraction or not. If I don't care. And you're right, I don't care. I will tell you this though. When I want to check the answer, I want the answer to be an integer because life is good. But this isn't that hard to plug in, because the moment you put it here, the times 3 and the divide by 3 cancel out. And you get negative 2 plus 6, which is 4. And the absolute value of 4 is 4. You cut it in half and make it negative is negative 2, and negative 2 plus 4 is 2. It's just not as quick. There it is. I was like, something's not right here. I forgot to distribute the negative sign to my 6. Did you do it too? I was like, I'm about to get the same answer. I've done something wrong here. Yeah. So let's add 6 to both sides. Now I'm really going to run out of space. Okay, can we all agree that you don't need to see me divide by negative 3?
It's better to see it than to...
I know, right? Where'd that 3 come from? The answer is negative 10 over 3. And no, you will not write a mixed number. Do not use mixed numbers. They're awful. I'm not finished yet, so there's no reason to pack up. But just so you know, mixed numbers are only useful for baking pies and changing oil. Other than that, I don't care. And I can prove it. What if I said to you that I needed, I don't know, 5/6 of your 3 1/3. Just leave it right there. That sounds awful, doesn't it? 5/6 of 3 1/3. But 5/6 of 10/3 is actually really easy because of just means times. The answer is 50 over 18. Done. Like I just did that in my head. But I don't know what 5/6 of 3 1/3 is. No clue. No, I just forgot it that fast. Yeah, it's like, for me, it's like student names, just gone. You know what I mean? I don't know. I do know your name. I won't know it next year, though. It's not because I don't like you. It's because there's no reason why your name is Daniel Q. No, there's not. It's just what your parents named you. It's just a fact I'm trying to memorize. Who? That's only because I knew you last year. Anyway. Yeah, but he was on my roster again. You think so? You give me my AP Precalc? Fingers crossed. I'm not teaching stats, Bill. I'm a mathematician, not a magician. That stuff is magic. No, I teach IB, my IB math class, there's stats in the second year. So in their second year, all they learn is prob and stats. But no, Westlake is prob and stat honors, so is Lash, and Lash is AP stats. Don't take AP stats unless you're a senior, though. Okay. Because after that, your math career is finished in high school, and universities want to see you take math all 4 years. Yes. Okay. Here we go. What makes this question different from the ones that we were doing before? You see it? What is it? There's an X on both sides, but more specifically, even more powerful than an X on both sides, there's an X on the inside and an X on the outside. That can create a problem sometimes. So let's see what happens here. Best case scenario, the number on the inside was positive, and the absolute value bars did nothing to it. Worst case scenario, the absolute value bars were hiding a negative number from us. Let's solve best case scenario real quick. Let's start getting x's to one side. What are we going to do? Anybody, come on. Subtract an x from both sides. Sure. I'm going to subtract an x from both sides, and what this tells me is that -1 equals 5. I mean, it's been a little while since I learned mathematics in college, you know, but last time I checked, that's not a true statement. So does that mean there's no solutions? No, it doesn't. Let's test this case. Now when we subtract x from both, I don't want to subtract x from both sides. Do you mind if I add x to both sides? Yeah, it doesn't really matter. You guys are used to getting your x's to the left. Let's go to the left. It's fine. Negative x minus x is negative 2x. And now I can subtract 1. Oop, almost forgot my negative sign. And then divide by 2. Negative 2. Neat. And then obviously, you check your answers. Let me tell you right now, when you have x's inside absolute value bars and x's outside absolute value bars, you must always check your answers. Why, Mr. Rem? Because the moment you stopped writing the absolute value bars, you eliminated the structure that would let you know if things were possible or not. Right here, if you eliminate these absolute value bars and you write out a positive and a negative case, you won't realize that your answers don't work until you try to check them, because the absolute value bars are what's stopping this from being a possible question. So we always check our answers. That one failed miserably. Let's check negative 2. Negative 2 minus 1, yeah, that's negative 3. Its absolute value is 3. And negative 2 plus 5 is also 3. You might be curious to know why there was only one solution. Tell me, the way I taught you guys to graph this, what would you say the quote-unquote slope is of absolute value of x minus 1? You'd say it's 1, right? What's the slope of x plus 5? 1. And when two lines have the same slope, they're parallel, which means they don't cross. So this thing was parallel on one side, and that's why they didn't cross. Y equals math number absolute value of x minus 1 and x plus 5 zoom 6. The red line will be parallel on one side. And that's why there was only one solution. Because over here, we attempted to figure out where these two parallel lines intersect. Thanks, nerds.